other respected faculty members, and all the PhD and PG students present here. Today, we are gathered here for an insightful session by your esteemed expert, Dr. R.V.S.S. Avadhanulu sir, on the topic Roots of Modern Computer and Mathematics in Ancient India. Now, I would like to invite our head of the department, Professor Pitam Singh sir, to share his valuable words. Please, sir.
A very good afternoon to all present here and who joined online this session. So, first of all, I would like to thank our guest speaker, R.V.S.S. Avadhanulu sir.
Thank you, sir.
And Professor Siddharth Kumar, Dr. B. Vasu, and all faculty members of the department and my dear students. So, जैसा हम सब जानते हैं कि we have deep root of mathematics in India. Our ancestors did well in this area of mathematics and computer science. So our speaker explored about this field, and we will learn from him how it is developed in India and how we can proud ourselves. We have already such type of the terminology or mathematics in ancient India. So again, I am very thankful today. We have the such expert of the area. So thank you, and I invite Professor Avadhanulu sir. Thank you.
Thank you so much, sir, for your inspiring words. Now, I kindly request Professor Siddharth Kumar, sir, to share your valuable thought with us. Please, sir.
So good afternoon and welcome, sir.
Welcome, sir. Thank you, sir. Thank you.
So just I will introduce a little bit about Indian mathematics and some roots. So so good evening to all, and head of department Dr. Basu, Sadev Padhi, Shubham Gupta, and other students. So our speaker is very renowned today, and he has got several awards. So then Basu will introduce him, but just let me introduce say a few words. Like the development of modern computers and mathematics has deep historical roots with significant contributions from various ancient civilizations. Ancient India, in particular, played a foundational role in the evolution of mathematical thought and computational techniques that inform many aspects of contemporary science and technology. Decimal number system, ancient Indian mathematicians developed decimal value system, which forms basis for modern arithmetic. The use of zero, shunya, as a numerical was first systematically conceptualized in India. Mathematicians such as R.V.S.S, Brahmagupta, Bhaskara II led foundational work in place value and zero. Brahmagupta in 7th century formalized rules for arithmetic operations involving zero and negative numbers. Indian algebra included solving quadratic equations, understanding progressions using symbolic notations. Sulb Sutra in 800 to 500 BCE included geometrical methods for altar constructions, effectively containing early forms of Pythagorean theorem. R.V.S.S introduced trigonometric concepts such as sine and cosine, which were precursors to modern trigonometric functions. Kerala School of Mathematics in 14th to 16th century, notably Madhava Sangama Grama, developed early concepts of infinite series and calculus centuries before Newton and Leibniz. They developed expansion for sine and cosine and tangent functions. The Pingala Chandra Sutra presented binary number systems and combinatorics related to poetic meter, prefiguring the binary logic of computers. Naya philosophy, with its emphasis on logic, inference, and epistemology, contributed to systematic reasoning approaches fundamental to programming and algorithmic design. Ancient Indian astronomers computed planetary positions using interpolation methods. Texts such as Surya Siddhanta contain trigonometric and algebraic calculations embedded in astronomical methods. The concept of zero and decimal notations transmitted through Islamic world to Europe revolutionized mathematics and enabled modern computing. Algorithmic thinking and binary systems resonate with logical structures of modern computing. Indian contributions have been acknowledged in evolution of computer science, cryptography, and computational mathematics. The main root of computing can be traced to combination of mathematical innovations, mechanical devices, and algorithmic thinking developed over centuries across various civilizations. Like in mathematical foundation for like number system, Babylonian and Egyptian numerals were only positional systems. The Hindu Arabic numeral systems developed in India, including the concept of zero, enabled efficient computation and record keeping. In binary systems, so that Pingala in the second century described binary numbers in poetic meter. Leibniz in 17th century formalized binary arithmetic, which later became central to digital computing. Logic and algebra. So Astrolalian logic laid the foundation groundwork for formal reasoning. And Boolean algebra, developed by George Boole in the 19th century, became essential for digital circuit design and programming logic. Euclid algorithm for computing the greatest common divisor is very much used in modern computing, and this is also so Indian mathematicians like R.V.S.S and Brahmagupta provided systematic procedures, algorithms for solving mathematical problems. Al-Khwarizmi, a Persian mathematician of 19th century, often called father of algebra, um, his name is the root term for the algorithm. And for mechanical devices like abacus, used in Mesopotamia, China, and other ancient cultures for arithmetic calculations. Um, and then Antikythera mechanism, an ancient Greek analog computer used to predict astronomical positions. And Pascaline and Leibniz wheel, early mechanical calculators invented in 17th century for addition, subtraction, multiplication, and division. So formal computing and algorithm automation. So Charles Babbage designed the difference engine and analytical engine, considered precursors to the modern computer, introduced the concept of programmable machine. Ada Lovelace developed the first algorithmic intended for machine and is considered the world's first computer programming. Alan Turing formulated the concept of universal machine called Turing machine, and that could simulate any algorithm, and laid the foundation for computer science and artificial intelligence. Claude Shannon applied Boolean logic to electrical circuits and enabling the design of digital computers. And vacuum tubes enabled the first electronic computers like ENIAC, progressed through transistors, integrated circuits, microprocessors, leading to modern computing device. Conclusion: the roots of computing are deep and diverse, blending ancient mathematical traditions, logical reasoning, algorithmic methods, and mechanical innovations. These foundational elements have evolved into the digital computing systems and underpin contemporary society. So these are some concepts about this. Now I invite Professor Dr. Basu to introduce the speaker, and then he will speak. Thank you very much, sir.
Okay.
Welcome again. Thank you.
Very nice of you. Thank you, sir. Thank you.
Yes, good afternoon, all. So I really very thankful for giving me this opportunity to meet we all here on a tremendous and a worthy topic, which is roots on modern computers and mathematics in ancient India. So I'm very privileged to introduce the speaker. He is not a speaker, he is anything. That means he is such a great personality. So he is one of the uh, so Bharat Mata ka jo bolta hai. So therefore he is such a person. So I am introducing his few words. He was born in Andhra Pradesh, 1948 September 25th. He did his MSc in nuclear physics from Andhra University 1969, and he did MA PhD Sanskrit and MA integrated PhD in astroscience, as well as Doctor of Literature, that honorary, so where which is called also that Vachaspati Award, awarded by the Rashtriya Sanskrit Vidyapit Tirupati. Now it is called National Sanskrit University. He has several positions held. So now he is working as the chief executive of Shri Veda Bharathi, an international institute of research and development training. And he was retired as deputy director and head of computers. So in the Nizam's Institute of Medical Science, Hyderabad, and he was worked as many positions as senior computer professional in ECIL, Electronic Corporation of India Limited, as well as JNU, Jawaharlal Nehru Technological University, and as a several positions he has. So since then, of completion of his PhD and the degree, and there are the professional experiences. He has executed national and international projects, 140 and more, and he was authored 70 plus books, 80 research papers, and 50 titles of Vedic recordings. So he has been guiding the students projects for MTech as well as MCA, about 40 and more. So he was conducting online courses in social media, about 800 hours recorded videos and more on Veda Vijnanam, Vishwa Vijnanam, Gita Bhashyam, Brahma Sutra Bhashyam, Rudra Bhashyam, Veda Ganitam, Lilavati Ganitam, Shri Vishnu Sahasra Bhashyam, etc. So he has some of the achievements, so which we can few. I would like to putting you in front of you. So that is, he is the first person digitizing the Vedas, recorded about 2,000 more hours since 1992. The first person to successfully introduce computer code for Indian languages. So it was done in 1976, and that particularly we can say that is the highly complex computer language Fortran 4. The first compiler he was designed in Hindi and the bilingual languages. Right, the first person to get the patent for designing multilingual multimedia Vedic database, as well as first person to correlate the concepts of computer science with Vedic Mimamsa, and first person to publish Vedic mathematics in Braille script. It is tremendous. We cannot say anything, no words for this, because not only our people, like all the normal people, but he has also served for the blind people also. So that it is not possible to write in Braille without knowing Braille. So therefore, he was studied, learned the Braille, and then he was written the book on the Braille. So therefore, there are many number of such books. He was written in the Braille, Vedic mathematics in Braille script. So since in 2013, so first person receives Golden Nandi Award for teaching Vedic mathematics. The first person to install telemathematics system in Andhra Pradesh. The first person to point a significance of Vaitrithri Yoga in earthquakes, right? First person to start many online modern education classes for students for Vedic schools. So about his contributions, there are many number of appreciations and awards. So which we can pointing here, I am giving you in front of you that appreciations received from President of India, Dr. Shankar Dayal Sharma in 1995. So appreciation received from Prime Minister of India, Shri Atal Bihari Vajpayee. Appreciation received from Official Language Committee of Parliament of India in 1976. So he has also received Sanskriti Mitra Award in 2003, Vachaspati Award from National Sanskrit University 2015. That Golden Nandi Award we have already told. So like that, there are many number of contributions. So for that, I would like to show you some of the awards received and his contributions. So in a video, so that you can see and validate that the things. So it will be very regard and prestigious, and it's my great pleasure to introduce such a personality. So to that, so nowadays we are all reading all the textbooks that modern mathematics and all. So that itself, people some feels, and some people may go into the top level, and all the roots of that modern mathematics, it has been clearly scripted from our Vedas, right? So therefore he will, I hope this lecture will clearly explore about the roots of the modern computers as well as the mathematics from our ancient India, right? Thank you very much. The video he will be playing, so that please see.
Thank you, sir.
Thank you
Thank
very
you.
much, sir.
Thank you, Professor Vasudhara. Thank you for your kind words.
Now I kindly request Dr. R.V.S.S. Avadhanulu sir to enlighten us with his expertise and share his esteemed knowledge with us. Please, sir.
Thank you very much. Respected Professor Vedam Singh ji, Professor Shivdat Kumar ji, and Dr. Vasu ji, and dear friends, it's a privilege for me to be with you through Zoom technology and share my experiences related to the computers and mathematics, in particular, actually, the roots of these subjects in our ancient India. Before starting the PowerPoint presentation, just a few words I would like to say. Sir, I had been to Prayagraj in 1975 for the first time. 1975 April. Today is 2025 April. So just 50 years completed by getting purified at the feet of Ganga Mataji in 1975. Here actually the subject that is taken for today's lecture, I have a passion for mathematics. I have a passion for Sanskrit. I have a passion for Vedas. In fact, my livelihood is only through computers. All these subjects actually they have integrated. And ultimately I found whole of my total career spreading over 55 years of service as on date, sir. I started my service in 1970 January. Today is 2025. All along, all these subjects have been guiding me. And great gurus have helped me. They blessed me. In fact, they molded me at various places in various directions. Before directly going into the subject, sir, I would like to show you one or two books which were published through Shri Veda Bharathi. Today we have taken up the topic as roots. What can be the roots for the subjects of computers and modern mathematics? Sir, I will show you a book. Just 1 second, please. Sir, can you see this book?
Yes, yes, yes.
Yes, sir.
This is Shabda Veda. This book size is, the length of the book is 2 feet and width is 1.5 feet and thickness is about 6 inches and weight is about 10 kgs, sir. This is the root for our entire knowledge that is brought out in India from ancient times onwards. So just actually have shown the root in the literary form. Preparing the book, exactly 30 years back, we have given the proposal to President of India, Dr. Shankaracharya Sharma ji. That also happened to be in 1995 April. He has, with his recommendation actually, and with the funding of government of Rajasthan, the work has started to compile entire literature related to our modern sciences in ancient India. The preparation time was 15 years, sir, it has taken. All the Vedic branches that were spreading throughout the world, actually they are decaying. At the time of beginning of Kali Yuga, say about 5,200 years back, our knowledge was spread through about 1,131 Vedic branches. Almost they survived for about 4,000 years, sir. But in the last 1,000 years, because of the foreign aggressions and foreign rule, and because of the change of our own mindset, previously it was a Dharma Kendra Samaja, it has become now Dhana Kendra Samaja. So these 1131 branches, about 1000 years back, they reduced it to about 11 or 12 branches at the time of our independence, 1947. They further reduced in their number by 1991. Only 7 branches are being studied throughout the world. Then again, at that time, actually, we started this project, preserve our Vedic literature and propagate the wisdom embedded in these sciences, in these Vedic shlokas. So like that, actually, we started about 34 years back, very seriously. But actually, studying this subject has started by me in 1950s, when I was in elementary school. God has given me the great opportunity to study within the limited scope what a human comprehension can proceed up to that limit. Actually, only small things we could collect. Even that itself is appealing to be and appearing to be a very great subject. This is a small introduction, sir. Based on this, so far already it was mentioned, I have brought out about 75 books. And within that, the mathematics itself, for like the Vedic mathematics, I have been propagating from 1972 onwards. I studied the subject of Vedic mathematics in 1971-72, written by Bharathi, our holy, His Holiness Bharathi Krishna Tirtha Swamiji. Originally, I have written one book, and then slowly I started expanding the subject. Now it is a set of 5 books in English. Then I have written a set of books on Leelavati Ganitam in English as well as in Telugu also. As already it was mentioned, the books on Vedic mathematics in Braille script, 5 volumes we have brought out, sir. 5 volumes. Actually, the joy what the blind people or blind students are getting at the time of touching the papers and then studying the mathematics. Actually, one should see to believe it. Actually, that is the place where I get joy, satisfaction. So, with this a small set of few words, now I will go into the share screen, sir, and the PowerPoint I will enter with your kind permission. Now, this meeting is held by the Department of Mathematics, MNNIT, Prayagraj. And this is a slide prepared by the department, the youngsters of that department. At the outset, I thank them for preparing this one. And the subject given is the roots of modern computers and mathematics in ancient India. And this is a presentation by me, a small set of degrees. Yeah. Here actually, let me start with the words of Einstein, sir. Amma కనిపిస్తుందమ్మా స్క్రీన్ కనిపిస్తుందా? Is this screen? Are you able to see?
కనిపిస్తుంది.
Okay. He says, we owe a lot to Indians who taught us how to count, without which no worthwhile scientific discovery could have been made. If the numbers themselves are not there, what will be the progress of the whole world? The fundamentals of the mathematics that was done by the Indians actually. That is the gist of the statement of Einstein. He is a mathematician of 20th century. But what of the mathematician of 19th century, Laplace? You know, Laplace is very much known for the mathematics and the equations related to the flow of groundwater systems, on which I also happen to work for a national laboratory, National Geophysical Research Institute, Hyderabad. He says, how grateful we should be to Hindus who found this great decimal system, which does not occur to the minds of such mighty mathematicians as Archimedes and Apollonius. Normally, people are of the impression that Archimedes and Apollonius are the greatest mathematicians of the whole world for all times put together. Laplace says, how is that these two great mathematicians could not get that idea of preparing the decimal system? Such a wonderful system was brought out by Indians. That is a statement given by him. Now about the civilized past, once we are saying ancient India, what is meant by ancient India actually? This is the Encyclopedia Britannica says. The greatness of our ancient India, he mentions. It's not that we boast ourselves. Let the neighbors boast us. Let the foreigners boast us. They say, if there is a country on earth which can justly claim the honor of having been the cradle of the human race, cradle means the birthplace, and where it is brought up, where it is nourished, that country is assuredly India. That is the way they look at India as one great country which has been the base for the growth and the expansion of all the sciences subsequently for the last several millennia. Yes, now the topic today, actually this is one book already I have shown you. Yes, related to the computers, I have written another book, Vedas and Computers. It contains the concepts of computer compilers in Vedic Mimamsa. Actually, we feel the computers are still evolving. The first computer has started from 1946 with the ENIAC, and subsequently Alan Turing has defined what is meant by a computer. Definition of computer was given by Alan Turing. Today, thousands and thousands of models of computers have come into existence. Everybody is using, but very few people know the definition of computers. Let me tell you one thing, sir, here. Actually, I will be quoting subsequently. The definition of computer was given in Vedas, which is unbelievable. Particularly in Vedic Mimamsa, it was well defined. The way it is defined today by Alan Turing is exactly. Its a translation is found in Mimamsa Shastra, which was written in this land about 5,000 years back, sir. Just only one sentence I am making. I will prove it subsequently. Here actually, one great shloka is there, sir. Very great shloka. I would not get a person who can type in Hindi letters, Devanagari. So I have written myself. Here, the shloka is Achintyavyaktarupaya Nirgunaya Gunatmane Samasta Jagadadhara Murtaye Brahmane Namaha. This is a Prarthana shloka, sir. Prarthana shloka, a prayer. And this prayer shloka was written about 3,000 years, sir. 3,000 years back, this shloka was written. In Surya Siddhanta, this is a prayer shloka. But actually, here actually the prayer means it must be for Paramatma. It says Achintya Avyakta. Actually, the words, if you see Padavibhaga, Achintya and Avyakta Rupaya. That is, who has no form, he is beyond imagination. Nirgunaya, who has no properties, who has no characteristics, but still he is appearing to be with all the characteristics, Gunatmane, and he is the base for the entire whole universe. Samasta Jagad Adhara Murtaye. My namaskaras are to that great Brahman who is maintaining the whole universe. This is the normal meaning of that prayer shloka, sir. No. Actually, this shloka is defining and indicating various subjects of mathematics, sir. Various subjects of mathematics are mentioned in this first shloka. Let me spend a few minutes at this shloka itself. Let us take the first line. Achintyavyakta Rupaya. Further split, Achintya and Avyakta Rupaya. Vyakta means which has manifested. Very clear. That is the number systems, the digits. All these things, they come under the Vyakta Ganita. Arithmetics. Vyakta means arithmetics. But here is that appear word is Avyakta, which is not known. You take the value as X or Y or Z, something we will say. We do not know the value of that X, Y, Z at that beginning, in the beginning. It is Avyakta. It is ultimately algebra. Similarly, Achintya. Achintya means which you can imagine. Achintya means which you cannot imagine. Actually, here now you see, what is the square root of -1? Can anybody imagine? No. Because our fundamental rule for the squares is either a positive number or negative number. If you square it, you will get only a positive number. And you want to take out the square root of it, you will get plus or minus. But he says here, actually, square root of -1 is there. Because we cannot imagine it. We call it an imaginary number. Imaginary numbers, they come under the complex numbers, a plus iv. A and b may be real. But once you put I is equal to square root of -1. We call it as imaginary. Actually, it's not imaginary, it's unimaginary, you should put it. Unimaginable, square root of -1. So the complex number system is indicated by the word achitya. Algebra is indicated. Arithmetics is indicated. And nirgunaya, which has no characteristics, which has no properties. What can be that subject? How do you define a point? We define point as a dimensionless. It has no length, no breadth, no height. But even that the point exists. We say, you put a dot using a pencil, very sharp pencil. If you take a microscope, you can find the dimensions. But we assume that it has no dimensions. So here nirgunaya means a point. Once one point is taken, it is a point, we call it. You have 2 points, we construct one straight line. You have 3 points, you have a triangle. You have 4 points, quadrilateral. Entire geometry starts with a point structures. That entire subject is covered by this nirgunaya. Then gunatmane. Guna stands for the gunakara. Gunakara is multiplication. Once multiplication is indicated means division is also indicated. Once gunakara is indicated means addition also indicated, because multiplication is nothing but the repeated addition itself. Once addition is implied, given, then it is nothing but negative subtraction. So once you use one word gunatmane, all the 4 fundamental operators, addition, subtraction, multiplication, division, they are all implied here under gunatmane. You see, sir, how fundamental the prarthana shloka is now, containing all the fundamentals of our mathematics. The foundations of mathematics are explained here in simple words. And next 2 lines, charanas, if you take, the samasta jagad adhara murte, whole world, it is based on this. Today, actually, I will say, the whole world is based on the computer systems. If the computer is not there, imagine, the flights will not be there. Your bookings will not be there. Train bookings, no flight bookings, nothing. Whole world will come to a standstill. That is nothing but the computer science. Samasta jagad adharamurti today is nothing but a computer-oriented subject and science. Brahmane namaha. Brahmane means not only Parabrahman, it is also a great subject. Brahma is a word that is derived from Brahma. Brahma means very big. Like that, a prarthana shloka, which is normally chanted without going to the meaning of it, the same shloka is giving various subjects related with the mathematics and the computer science also, sir. Now, next one, you have given us the title, Ancient India. What is meant by ancient? Are the people clear what about ancient India? No, definitely I can say. Is it this India today where we are calling with fixed boundaries of as on today? Is it this India about 20,000 years back or 1 lakh years back? No. Because territorially, that is entirely the ancient India is different from modern India. You see here, the total area of ancient India is about 72 lakh square kilometers. And today's existing territory of India is 32 lakh square kilometers. Percentage wise, today's India is only about 45.5% of the ancient India. That is 55%, 55 or 55.5 or 54.5 of ancient India is today outside this present India. So once you say ancient India means the other countries that are to be covered, They include Pakistan. They include to be covered Bangladesh, Gandhar, Afghanistan, several other countries. Now you can see, then they got separated from this country. Gandhar, Afghanistan got separated in 1739. Sri Lanka got separated in 1936. Till such time, it is part of this country. Burma became independent in 1936. West Pakistan 1947. East Pakistan 1947, further in 1971. Tibet 1960. Bhutan 1960. Ladakh occupied by China 1962. All these things put together that constitutes our ancient India, sir. So once you say that roots of mathematics and computer science means I have the choice to select the scientists who are born in those lands also of those times. Now India's great inventions with respect to mathematics, sir. Now let us go stage by stage. Everybody says zero, numbers, and decimal number system. We say in English words, but do we have that shloka or mantra with us? Yes, this is the mantra, sir, that gives the names of the numbers. Actually, in the southern South Indian chanting is slightly different from North Indian style of chanting, sir. Because we belong to this area, I follow and I just chant out. Ekasmai swaha dvabhyagu swaha tribhya swaha chaturbhya swaha panchabhya swaha षड्भ्य स्वाहा सप्तभ्य स्वाहा अष्टाभ्य स्वाहा navabhya swaha, dashabhya swaha, like that it goes on. Yes, this is the part, this is the mantra found in Yajurveda. Yajurveda was having several branches. Within that one branch is called as a Taittiriya branch. And within Taittiriya Samhita, each Veda will have 4 parts. Part 1 is called as Samhita, part 2 is called as Brahmanam, that is the text, name of the text. Part 3 is called Aranyaka and part 4 is called as Upanishads. And part 1, the Samhita part of Taittiriya Shakha of Yajurveda. Yes, in 7th Kanda, 7th Kanda, 2nd chapter, it gives the list of names for the numbers, sir. This is a specific ID code for all the numbers. Who invented Yajurveda? Nobody knows, nobody can give the date. Yes, like that actually he has gone up to several numbers, up to 20, then again he goes in steps. So if somebody wants the source for the numbers, yes, definitely we can show and then start with this itself. Actually, these are all the mantras related to the decimal number system that is found in Taittiriya Shakha of Yajurveda. Several mantras. The entire chapter is filled up with the numbers only. Mantra is in Sanskrit. Now, again, odd numbers. Yes, for odd numbers also again he has given. Ekasmai swaha, tribhya swaha, panchabhya swaha. That is 1, 3, 5, 7, like that. Odd numbers also, that is, they have that knowledge of even numbers and odd number system also. Then, just a minute. Even numbers also. Dvabhyagu swaha, chaturbhya swaha, षड्भ्य swaha, अष्टाभ्य swaha, 2, 4, 6, 8, 10, 12, like that it goes on. They have clear knowledge of these odd numbers and even numbers. And then there is one mantra which normally when we go to Lord Vishweswara in Varanasi or Rameswara, in all the Shivalayams, when we go and they make Abhishekam, then one mantra is there that is chanted. Ekacha dasashatancha sahasrancha ayutancha niyutancha prayutancha arbudancha nyarbudancha samudrascha madhyancha antascha parardhascha tanme manasya sankalpamastu. It is nothing but a set of numbers with the powers of 10. 10 to the power of 0. Here actually I would like to say one or two words here. In our English system, we have the words 1, 10, 100, 1000. Once the mathematics always stands for precision. Very precisely you should be able to explain a number. And there should not be redundancy. No repetition is acceptable. So for every position in the decimal number system, you are supposed to have one unique name. It is 1. Yes, it is called as Eka. We append 1 0. A different name is given, Dasha. One more zero you append. That is 1 followed by 2 zeros. A further different number, shata. Further level, next level, 10 to the power 3. That 1000, sahasra. Yes, sir. Please stop. Once you have followed 1 followed by 1 4 zeros, what you call it, sir? 10,000 you call it. 10 is already used word. 1000 is already a used word. To express 1 followed by 4 zeros, you are using 2 words which are already used. You are going against the principles of fundamentals of mathematics. No redundancy is acceptable, but you have the redundancy. Do you have any other word to express very clearly 10,000? Any other word? In English, we don't have. Whereas in Sanskrit, particularly Veda has given, the decimal number system much more powerful than the modern systems are. It is called as Ayuta. You have one more zero appending. At least in Sanskrit, we may call it as Laksha or Niyuta. So, they have defined the decimal number system positioning with unique words up to 10 to the power of 19, sir. 10 to the power of 19. No repetition. Eka, cha, dasha, shatan. Now you can see. Eka, dasha, shata, sahasra. 10,000 is not dasha sahasra. It is called Ayuta. Next is called Niyuta, Prayuta, Arbuda, Nyarbuda, Samudra. Madhya. Samudra is a word standing for some numbers, sir. 10 to the power of 9. Madhya, Anta, Parartha, Ushas, Vyushti, Udeshya, like that it goes on. These things, most of the people are not aware of these words used in the decimal number system of our ancient India, sir. Actually, our mathematical number system is further improved. I cannot say improving, further strengthened by the great sage Valmiki through his Valmiki Ramayana. Valmiki Ramayana definitely deals with the story of Sita and Rama. No. Actually, if there is no Valmiki Ramayana, our mathematics must have been much, much poorer. Actually, after studying, going through the entire Valmiki Ramayana, you will find ultimately whether Valmiki has a thought of preserving the mathematical systems in Ramayana. For that purpose, he must have written this Valmiki Ramayana, we feel. In Yuddhakanda, 28th Sarga, from 33rd shloka to 38th shloka, he has defined the number systems, sir, the powers. Now you can see, there he says, 1 koti. Koti means 1 crore. 1 followed by 7 zeros, 10 to the power of 7. Then he says, 1 lakh crores. It is called as Shanku. 1 lakh means 10 to the power of 5 multiplied, 10 to the power of 7 into 10 to the power of 5, you get to 10 to the power of 12. Then like that, Laksha Shankus, you will get Mahashanku. Laksha Mahashankus, you will get 1 Vrunda. Laksha Vrundas, you will get Mahavrunda. Laksha Mahavrundas constitute Padma. Laksha Padmas constitute Mahapadma. Like that, I already have reached 10 to the power of 37, sir. The power is increasing by 5. 1 lakh times each over the previous one. Then Kharva, Mahakharva, Samudra, Ogha, Mahaugha. Up to that point, he has defined, sir. He has given the list. Valmiki Maharshi. We are supposed to know and we are supposed to teach to our children these names also. If we are really interested in spreading our ancient Indian knowledge, sir. Next goes. So far, we have touched only the number systems. And India's great inventions of next level. Who must have invented A plus B whole square, sir? Who must have invented? You ask any children, any child in the school, nobody quotes India. Nobody quotes Indian. That is an unfortunate situation. Are we aware of this invention of this A plus B whole square or the development? Actually, you can say, sir, a person by name Professor Donald Knuth, he has written a book called as Fundamental Algorithms. In 1960s, he has written that book. There he has given the history of A plus B whole square, sir. It is unbelievable. Normally, once you expand A plus B whole square, A square plus 2AB plus B square. The coefficients, if you take 1, 2 and 1, Similarly, a plus b whole cube, if you take a cube plus 3a square b plus 3ab square plus b cube, the coefficients are 1, 3, 3, 1. Normally, we call them as binomial coefficients. They form a pattern. Pascal's triangle, normally, you ask any child, yes, they say, yes, these numbers, the pattern, they constitute a Pascal's triangle. Pascal belongs to 17th century. Now, the author, Donald Knuth, writes, sir, it's not myself saying, he says, but whereas these numbers 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, all these set of patterns, they are all known in Europe in the 15th. So for the numbers known in 15th century, there is no need for Pascal. Pascal's name is cut off. He is not the inventor. Next level he has mentioned the same numbers 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, etc. So and so. They are all known in 14th century in China. The history, actually, we are going back into the China, into history, sir. A plus b whole square. And further he says the same numbers were known in India in 12th century, these binomial coefficients. And he mentions the name of Bhaskaracharya. Bhaskaracharya is genius. He has mastered 36 subjects, sir. 36 subjects. And all these coefficients, what just so far we have been mentioning, they are all mentioned in the Leelavati Ganitam, section 6, 6th Prakarana, and 4th chapter has mentioned. That is, these numbers are known in India in 12th century itself, the binomial coefficients. So we may feel happy, yes, a plus, once the coefficients are known means the powers a plus b whole power of n. The concept is known in India in 12th century itself. But the author says, no, Bhaskaracharya is not the person who is going to get the credit. He mentions one more name. That name is called Harayuha. How many people know the name of Harayuha, sir? He is a mathematician born in this country in 10th century. And it's not an original book, he has written a commentary, just like a guide for the textbooks in high schools and colleges we will be getting. Similarly, he has written a commentary, Vyakhyanam. And the Vyakhyanam was originally meant for the Chandas Sutras, prosody. There he has mentioned all the same coefficients, 1, 2, 1, 1, 3, 3, 1, 1. So now the history of a plus b whole square so far has gone up to 10th century AD. But when we find it is only Vyakhyana Grantha, we would like to find what is the source. That is Chandas Sutras. Chandas Sutras were written in BC period. So the history of A plus B also goes back to BC. And they were found in the original textbook called as Chandas Sutras, written by Sage Pingala. People say that he belongs to 8th century BC. History actually was not recorded in India earlier. It is a disputed times. Some people quote 8th century, some people may quote 2nd century, but anyway, it's more than 2000 years, sir. So, once the name of the scientist, a Saint Maharshi, Pingala Maharshi, actually is said to be the person who has prepared the original text for the Chandas Sutras, he is aware of the A plus B whole square, A plus B whole cube, etc. What does he mention? He says, no, I am not the inventor. Whatever I learned from my gurus, the same just I put it on paper. He has mentioned it. He is not the first person, he says. When he himself is not claiming, then how can you say the author of this A plus B whole square? He mentions this subject is known in India much earlier to him. So it is beyond 8th century BC. Just remember this, sir, up to this point. But we cannot pinpoint who exactly must have identified these binomial coefficients. And now, third level, great inventions with respect to mathematics. The binary system used in this Chandas Sutras again. Now, what ultimately binary system it is zeros and ones. How this concept of binary number system has come. Normally, we see as on today we are having English having 26 alphabets. Telugu is having 56 alphabets. Some other language is having 36 alphabets. Like that. But that scientist actually, the Maharshi, got the idea. Why so many letters? can't we represent and can't we convey the message with just two symbols? And he called them as Laghu and Guru. With that concept, actually, entire Chandas Shastra, you may call it as Anushtup Chandas, Jagati Chandas, Pankti Chandas, or Bharathi Chandas. Whatever Chandas you see, ultimately they belong to either Guru or Laghu notation only. That Guru is represented as 1 and Laghu is represented as 0. There started the binary number system, sir. Today, whole world, as I told you, is just running because of the computer system. Your total set of our smartphones, the circuits are functioning with the binary number system only. Samasta Jagad Adhara Murtaye, that's what I was mentioning. So this by identification of a binary number system itself is a great invention, sir, that started in India. Here I should say one more thing, sir. You ask any child, who is the father of computers? Immediately they will answer, Charles Babbage. Why he is father? Because he introduced the formula for computers. What is that concept? It is a stored program concept. That concept was given by Charles Babbage, so he can be called as father of computers. Now I am asking one more question, sir. If he is the father, then who can be the grandfather of computers? If there is a father, there should be grandfather also. If the entire computer systems are based on the fundamental concept given by Charles Babbage, on what base actually this Charles Babbage is standing? The stored program concept is depending totally on the binary number system. If there is no binary number system, there is no stored program concept. If there is no stored program concept, there is no modern computer system at all. So for the entire computer system, lower level is the stored program concept and its base is binary number system. So the author of this binary number system should be called as grandfather of computers. If somebody comes with any different claim, yes, let them come. If he can convince us, we will change. Till such time, let everybody accept this. So this is, and the Ganas also is very well known. Yamata, Rajabhanasa, Yagana, Magana, Tagana, Ragana, like that. In Ganas, actually, we call them. Next, sir. This is so far one level of our great inventions which have changed the whole world. Another great invention is the progressions, sir. That also is found in Yajurveda. Arithmetic progressions, geometric progressions. In arithmetic progressions, actually, again, I am showing you one mantra here, sir. See, I have gone through only the Taitri Shakha, I have not gone through other Shakhas. Similar mantras must have been found in other Veda Shakhas also. In Atharvana Veda, in Sama Veda, in Rig Veda also, plenty of number of mantras are mentioned relating to the number systems and these progressions. Here it says, it is arithmetic progression. Tribhya swaha, panchabhya swaha, saptabhya swaha, navabhya swahika, dashabhya swaha, trayodashabhya swaha, panchadashabhya. That is here, 3, 5, 7, 9, 11, 13, 15, like that is going on. Similarly, for the geometric progression also, as I told you, the same mantra which I chanted, Eka, cha, dasha, shatancha, sahasrancha, like that it goes on, giving it powers of 10. Similarly, in Rudravishaka also one more mantra is there. People will be bringing the coconut water and other things and pouring on the Shivalinga. That mantra is Eka Chame Tesrashchame. Most of the people may be scholars here who are participating in this meeting now. They immediately they can recollect. Eka Chame Tesrashchame Panchachame Saptachame Navachame Eka Dashachame Trayo Dashachame Panchadashachame Saptadashachame Navadashachame Eka Vigumushi. Like that it goes on. This is part 1. Second part is there. That is here it is in steps of 2. Arithmetic program A plus n minus 1 into D. The step value is 2 here, starting with 1. Second part is me chatasrashcha me ashtaucha me dvadashacha me shodashacha me vigumushitishcha me chaturvigumushitishcha me ashta vigumushitishcha me. It goes on. 4, 8, 12, 16, 20. Starting one is 4 and a step of 4. That also is progressions are found here. And the infinity, the concept of infinity itself, how can you visualize infinity. First of all, how do we explain a concept of infinity to the children who are studying in our high schools or colleges? Are we clever in our own imagination? How do you say? Somebody says infinity. Yes, we are also saying infinity. But how can you conceptualize it? Can you visualize it? Bhaskaracharya has given a clue to us in his Leelavati Gantam. I didn't have the Devanagari script as today, but actually you can find it in Leelavati Gantam. Regard the shloka I read out. It is typed in Telugu. Asmin Vika, it is a Sanskrit shloka. Asmin Vikara Kahare Narashavapi Pravishteshvapi Nisruteshu Bahushvapi Syalaya Srushtikale Anante Achyute Bhotaganeshu Yadvatu. Here it is Kahare. Ka means 0. If a number is divided by 0, 1 by 0, 2 by 0, n by 0 ultimately, what is the value? We call it as infinity. That actually he is mentioning it. That is called Ananta. How can you visualize it? That he has explained. Where he has explained it. He mentions Sri Mahavishnu is there. He is supreme. He is a person actually, because of him only the creation, the Srishti, Sthiti and Laya will be happening. Srishti means something coming out from him outside. He is creating. The creation is outside him. And Pralayakala, the outside thing goes into him. The shloka says, suppose he is having some weight, let us say, his weight is X. Imagine, from him the whole universe, not one universe, several universes are coming out. Let the weight of all the universes that have come out of him be, you call it as Y. So he must be less by Y. So he must be having, after creation, his weight must be X minus Y. Is it not? Original weight is X. And the weight of all the things that have come out is Y. So he is reduced by that much weight. So X minus Y must be the resultant weight. No. Then also he is X only. Similarly, at the Pralayakala, the outside items, let us say you call them as, say, some P. His weight, let us say you call it as Q. All these things, all the lokas, they go into him. Then his weight must be totally, after Pralaya, it must be Q plus P. No, then also it is Q only. As he was earlier, he is the same way, either before Srishtikala or after Srishtikala, or before Pralayakala or after Pralayakala. Because his weight is infinity. Infinity plus anything is infinity, and infinity minus anything is infinity. This concept actually, with the illustration of Sri Mahavishnu, explains in Leelavati Gantam and other places. These are the great concepts, sir. Unimaginable how they got these thoughts. It's not in 1 day or 2 days it has come out. They have taken several, thousands of years hard work by great intellectuals of this land that has brought out this mass mathematics of this highest order. Now the super fast techniques, Vedic mathematics, everybody is familiar. Now here I don't want to spend much time on this. Everybody knows, particularly mathematics department people. Yakadhikena Purvena. These are very popular sutras given by our Bharathi Krishna Tirtha Swamiji. 35 to 35 is good, how much? For teaching to the children, normally they fill up the blanks technique. There are 2 digits in the first number, 2 digits in the second number. The answer cannot exceed 4 digits. So first down, write down 4 blanks. You multiply 5 into 5, 25, put on the right side. Then out of 3 into 3 only left out. One number you increase by 1. Yaka adhikena purvena. Previously it was 3. Now you add yaka adhika 1. It becomes 4. The second 3 will be like that. 4 3s are 12. So ultimately the answer will be 12 or 25. A simple technique. These are all the concepts actually given through illustrations, several techniques. Similarly, Anchivar Dasikepi, 27 to 23. Who knows actually? Normally in our schools, nobody teaches. The multiplications are taught only up to 10 by 10 or 12 by 12 or maximum 16 by 16. But for competitive exams, these Vedic mathematics is helping a lot. Almost every student appearing for the competitive exam, they are learning Vedic mathematics and then they are going for it. It's not that all the questions will be coming in only from Vedic. One or two questions are sufficient. Then lakhs of candidates are appearing for the competitive exams. One mark also will count. Definitely, he may aggressively go thousands of ranks forward. If he doesn't know this Vedic mathematics, he may go behind. So there, this Vedic mathematics is very much helping, sir. Several techniques are there. Antiyor Dashikepi. I'm not spending my time on this subject now. Yaka Nyunian Purana is a wonderful sutra. 99 into 27. How do you get the answer? Yes, if the pattern, just I'll explain very briefly. Suppose there are two numbers which are to be multiplied. One number is all nines. Second number can be any other number. It may be the equal number of digits or more number of digits or less number of digits. Suppose you have equal number of digits. In such a case, how to do? Yes, that 99s, you keep it in this line. Whatever number, other number is given, reduce it by 1. Yaka Nyona. Nyona means less. 1 less. 27 is given, you write it 26 here. Where do you write? Under the nines. Then go on subtracting from the top number, top digit to bottom digit. 9 minus 2, 7. 9 minus 3, 6. 3, you will get it. Ultimately, the answer is 2673. That is, actually, the mathematics is having two types of examinations. One is where with the proof, with the steps, all these things which are to be written in our normal examination system. That is essential. But whereas in the competitive world, if you start writing all the steps and other things, yes, your time will be over. Immediately you will ask you to vacate. There, this Vedic math is fundamentally helping everybody actually. Like this, there are several techniques related to. So now let us remember recollect the great contributors of this mathematics in this land, who are the great mathematicians or astronomers. Astronomy is nothing but actually the expansion of our mathematics only into 3D orientation. Here, Surya Siddhanta, which I mentioned previously for the Prarthana Shloka, therein actually they have calculated the Earth's diameter was mentioned as 7,840 miles, whereas with the modern gadgets, it is identified as 7,926. Almost very close to the original number, they could get it. Similarly, the distance between the Earth and the Moon, it was given as 2,53,000 miles, whereas today, average, it is 2,52,710 miles. In the absence of any modern gadgets like computers or calculators, they were able to do it orally or mentally. That is the power of our the power of our mathematics in ancient India, sir. Similarly, Bodhayana, he calculated the value of pi first and explained the concept what is known as the Pythagoras theorem. He discovered this long before the European mathematicians. This was validated in 1999. Actually, Pythagoras was born after 3 centuries after Bodhayana. Bodhayana's Solva Sutra is there. Pythagoras was born after 3 centuries after Bodhayana. It should be called as Bodhayana theorem, not Pythagorean theorem. But actually, our names are suppressed. Similarly, how you can see just a list of names who invented the mathematical principles first, but whose names are not mentioned or whose names are suppressed. Govinda Swami, he belongs to a period of 3rd century BC. He is a person actually found out certain thing, which is now known in the name of Newton-Gas interpolation formula, sir. Actually, this Newton is born after 1800 years after this Govinda Swami. And there is a record that Govinda Swami has identified the formula. But even then, it was forcibly applied. The old name was suppressed and the new name is given. Several things are there, one by one. Aryabhata, there are 2 Aryabhatas, sir, not one Aryabhata. Aryabhatta 1 is belonging to 5th century. Aryabhatta 2 belongs to 9th century. He is a person actually who has mentioned heliocentric theorem, Surya Kendra Siddhanta. And Copernicus actually, he was born after 1,000 years after Aryabhatta. But even then, today is known in the name of Copernicus only. And Bhaskaracharya 1, he belongs to 5th century. He calculated the time taken by Earth to orbit the Sun hundreds of years before the astronomer Smart. And he has given time taken by Earth is up to several decimal points he has given. 365.258756485 days. Up to microsecond level he has calculated. Or nanosecond also. Similarly, Brahmagupta, he explained the positive and negative numbers and their calculations in his Brahmaspata Siddhanta. Vateswaracharya, he belongs to 7th century AD. That is about 1,000 years before Newton. But his formula, Vateswara's formula is now known in again the another name of Newton gas, backward interpolation. Similarly, Sridharacharya, he belongs to 11th century. He is a person actually who has brought out the quadratic equations. Ax square plus bx plus c is equal to 0. What is the value of x? Minus b plus or minus the square root of b square minus 4ac by 2a, we call it. Those things he has already explained. Wonderful contributions that they have given. Bhaskaracharya too, as I told you, is genius of genius. Just a minute. And similarly, Madhavacharya, he belongs to 12th century. He discovered the Taylor series of sine and cosine. Actually, no, sir, I can say one thing, sir. Recently, I am asked to teach. Incidentally, one thing I can in between I can tell. Recognizing the contributions of Indian mathematicians. About 5 years back, we have submitted a proposal to Tirupati Sanskrit University. Sir, why can't you? It's a Sanskrit university teaching always Tarka, Vedanta, Jyotisha, Sahitya like this. Why can't you introduce something related to our modern mathematics also? 5 years back, we submitted a proposal. They said, no, our UGC has to approve the proposal. Okay, you please forward it. Let them decide. The proposal given by us was forwarded to UGC. They accepted it. So after getting the acceptance from the UGC, immediately Tirupati Sanskrit University, they started. They started a 3-year degree course, sir, Indian mathematics. Normally for BSc, we have 3 subjects, MPC, Maths, Physics and Chemistry, or BZC, Botany, Zoology, Chemistry. Like that, there will be 3 subjects. In some colleges, there will maybe double mathematics, M1, M2, P. M1 means first mathematics, M2 is second mathematics, P means physics. 3 subjects must be there. Interestingly, this university, the M1, M2, M3, all the 3 subjects, they belong to only Indian mathematics only. Such vast literature we have given. We prepared the syllabus. Already 2 years are over. Now the students are appearing for the final exams of the 3rd year, sir. 3rd year, I started teaching them. There in Indian trigonometry also I explained. I taught them online. Therein we find the names of all the great acharyas, Madhavacharya, Munishwara, who contributed significantly for the trigonometry. Not only 2-dimensional, spherical trigonometry, 3-dimensional. We do not know, we have gone through, we never gone through the Sanskrit verses related to the mathematics, sir. Only the translations we are studying. It's unfortunate. Somewhere we pray a day should come where we learn mathematics in Sanskrit also. We are not against English, but at the same time we are fond of Sanskrit. It is our motherland's beloved language. We should know. Then he has discovered the sine and cosine functions. Similarly, Newton power series. All these things are mentioned there, sir. Nilakantacharya, several times his name is referred in our mathematics. Newton's infinite geometric progression and convergence series he has introduced in 15th century. So like this, actually, some of the great names who have contributed for the subject of mathematics in ancient India, I could bring it before you, sir. and who are the great other mathematicians with respect to the space, astronomy, where the spherical trigonometry is essential. Lagadha. How many people know the name of Lagadha? Pitamaha, Vyasa, Atri, Narada, Marichi, Angira, Paurisha, Vyavana, Shaunaka, Kashyapa, Surya, Shakalya, Vasishtha, Parashara, Garga, Manu, Lomasha, Chavana, Bhruvu, Paulasya, Kolaha. These are all the great sages. We treat them with respect. And there we leave it. We don't care for the subjects contributed by them. We never go through the writings of these great people. Similarly, Aryabhata onwards, yes, we are familiar. Aryabhata, Varahamihira, Bhaskaracharya, 1, 2, Vishnugupta is nothing but Chanakya, Siddhasena, Manitha, Sri, Chanakya is a great mathematician and astronomer. Manitha, Srijidhvaja, Kalyana Varma, Simha Telakasuri, Kalakacharya, Mahaviracharya, Bhattotpara. He is a great mathematician of 9th century in Kashmir. He has written great commentaries for several mathematicians like Varahamihira. All the books were Devaswami, Jiva Sharma, Satyacharya, Prithvi Prithvi is the son of Varahamihira. Like this, actually, sir, we got our great Shankar Balakrishna Dikshit of Maharashtra. In 1890, he has written a book on the history of ancient Indian astronomy. He got an award at the time. I do not know how many people had the name of that great person. For job wise, actually, he was a small clerk in an elementary school. He was a small clerk. But his knowledge is so profound, he got an award. In 1890, you know how much amount, sir? One award, first amount was 450 rupees. At that time, 10 grams gold was costing 1 rupee. Today, 10 grams gold is costing 1 lakh rupees today. He got 450 rupees award, sir. First award. Immediately, second person has given another 1000 rupees. 1450 rupees cash award he got. Shankar Balakrishna Dikshit. In 1890, in Bombay, not far off place. What he had done, you know? Actually, how many kilos of gold must have come even at that time? No, he didn't care. He collected about 3000 manuscripts of great mathematics of India, sir. That is the contribution. He collected the manuscripts, brought out a big library. Actually, most of the books are not yet printed. Lot of research can be done on the collections what he has done. And if some books are not yet printed, yes, some organization can take the lead and then proceed further. Similarly, excellence in mathematics and astronomy. India, as I told you, 1000 BC Surya Siddhanta. Yes, these are the Sholva Sutras, Bodhayana. As on today, actually previously, let me tell you, sir, about 5000 years back, on geometry, Sholva Sutra means, Sholva means rope, card, C-A-R-D, card. Sholva Sutra, almost a thread, you can call it. That is, the geometry was carried out using a thread or a rope. About 1130 books were there about 5000 years back on geometry. But today only these 7 books are traceable, sir. The authors' names are Bodhayana, Apastamba, Katyayana, Vadhula, Manava, Maitrayana, Varaha, and Vadhula. 8th book on geometry, Sholva Sutra, is not found, sir. The books were burned to ashes. Similarly, actually, we got a long list of about 150 great mathematicians who were born in this country over a period of last 5000 years, sir. Here in this context, I may mention, we have brought out the contribution of Balasankar Dikshit. Here, just I will show you, sir. This is a great one volume we have translated into Telugu. Similarly, there are two volumes are there. It is 2000 pages. Matter he has brought out, sir. Shankar Balakrishna Dikshit. Actually, we feel bad when we look at our pitiable condition of not knowing the contributions of our own great people. It's unfortunate, sir. This is so far with respect to mathematics, sir, I have told. And as a successor of great mathematicians, we got Srinivasa Ramanujan, followed by Bharathi Krishna Tirtha Swamiji. And now here you see, now I am entering into the field of computers also, very briefly, sir. Actually, we feel that Charles Babbage has started contributing for these concepts of computers. What are the components of computers? One input device, one output device, one processing system, CPU, we call it. And then the speed, another important, the command, specific action to be taken out. But interestingly, sir, you mention a concept of computers, you will find its perfect equivalent in Vishnu Sahasranama Stotra. You mention a concept, you will find it. Sir, a command, these are the things normally we deal with in the computer field. I got the computer training in 1969, sir. I completed my MSc in nuclear physics in 1969. Immediately I got my training in computers, 1969 itself, about 56 years back. Okay, sir. From that time, actually my lifeline is computers only. From 1971, only for 1 year I worked as physics lecturer. But subsequently I am in the field of computers only from 1971 onwards, last 54 years. I have been living with the computers. Thousands of computer models I have operated. Thousands of computer packages I have used. And simultaneously I studied the books related to our Vedic literature, that is Mimamsa Shastra. The words which you are familiar with the computer, command, memory, a programmer, data storage, cabling, speed. Actually, for all these things, there are perfect equivalents, sir. Command means Radha Spashtaksharo Mantras Chandranshur Bhaskara Spashtakshara. A very clear meaning. That is the command. What is meant by command? What is meant by command? There are several words are there in the dictionary. Every word in the dictionary is not a command. Study, write, fire, kill. They are the commands. Where action is involved. That is the message to be conveyed by that word must be very clear. Suppose the curfew is imposed in some place. Suppose the superior officer asks the subordinate, start firing. Fire, he says. Then there should not be any seminar. Sir, shall we fire? Or fire in this direction only? Is it necessary to fire? No questions there. He ordered, he implement it. That is called Spashtakshara. Similarly, memory. Sumedha medha jodhanya satya medha dhara dhara. Sumedha in Vishnu Sahasranama. These are all the quotations you can pick up. Programmer, ultimately, a person who knows the usage of these commands, suitable to solving the problem, that we call as program. Mahakramo, Mahakarma, Mahateja, Mahoraga. Mahakrama, he is an expert. Lord Vishnu is a Mahakrama, he is an expert programmer, not ordinary programmer. Data storage. Like that, actually, cabling. Swatanto Stantu Vardhana. Speed. Vagavan Amita Ashana. Sumedha Medha Jodhanya Satya Medha Dhara Dhara. Like that, actually, every word of the computers now is found in our Vishnu Sahasranama Stotra, sir. But our other concepts in Vedic Mimamsa, as I told you, the first concept is, sir, how do you define a computer? I am not asking how you are using the computer. No. Define a computer. There are millions and millions of machines are there. Millions and millions. But they are not the computers. This particular instrument we are calling as a computer. What is that one? What definition actually differentiates this machine from others? While the first computer has come into existence in 1946, the definition of this computer is given by Alan Turing in 1952, after 6 years after the Avirbhava of the computer. He says, a machine which has an input system, which has an output system, and in between which has a processing system, that system can be called as computer. This is the Alan Turing definition, sir. Sir, I worked as a professor in Jawaharlal Nehru Technological University. and teaching the subject of mathematics, computers. అమ్మ క్లాసులో ఉన్నాను, నేను క్లాస్ అయ్యాక వస్తాను. ప్లీజ్ వెయిట్ చేయి. I was teaching the subject of computer science to the MTech students. All these subjects, what I learned actually through the official freedom, actually I got it. I taught them. But when I subsequently studied Mimamsa Shastra, I wondered there it has given the definition given in Mimamsa about the computer. I am saying bhavana, the word they called as bhavana. Sadhyam, sadhanam, iti kartavyata. Sadhyam means which you are supposed to achieve. To be achieved is called sadhyam. Sadhanam, instrument which is available to you. Sadhanam actually, that is which is available to you, that is input. Sadhyam, which is you are going to achieve, which you are supposed to get, that is called output. Iti kartavyata. How do you proceed? Given these instruments to you to reach the target, how do you proceed? The methodology, that's called the processing, that is given by iti kartavyata. We wonder actually how they got the concept of computers, maybe for a different purpose in Mimamsa Shastra. A computer actually, once you write 7 programs, your types of Vedic statements, input statements will be there, assignment statements will be there, decision making statements will be there, IO statements, input output statements will be there. Equivalently in Vedas also we have got Vidhi Vakya, Mantra Vakya, Namadheya Vakya, Nishedha Vakya, Arthavada Vakya. The perfect correlation between the two, sir. Similarly, the statement of injunction. How many types of injunctions are there? All those things are. It is called Utpatti Vidhi, Vinyoga Vidhi, Prayoga Vidhi, and Adhikara Vidhi. Even the password concept was mentioned in our Vedic literature, sir. Password concept. What is meant by password? Whether this file is somebody is authorized to open that file or not. If he is given a password, then only he is eligible, he can open that file. The similar system was mentioned in our literature. Suppose I want to perform Rajasu Yaga or Ashwamedha Yaga. No, you are not eligible. The eligibility criteria they defined, that actually the concept equivalent to our password. Like that, I got about 71 concepts of our computers found in our Mimamsa Shastra, sir. Similarly, this is what I was mentioning between the computers and the bhavana concept. Input is a sadhanam, output is a sadhyam, and the processing is called iti kartavyata. Similarly, statement recognition. When you are writing a statement in C language or C++, how does the computer understand it? That is, assignment statement code is to be generated or decision making code is to be generated. First of all, how does it identify that this sentence is, the statement is terminating at this point? By the end of by you are pressing the enter button, at that it is taken as one delimiter, we call it, delimiter. Then it takes on the lexical analysis, syntax analysis, semantics analysis, conducting all these things, then ultimately it identifies what type of statement it is. Accordingly, it generates the code, subject code. That object code has to be converted again to using the linkage editor. Finally, a run model that will be generated. That executes, you get the results. All these things are very well defined in our Mimamsa Shastra, sir. I studied only one small book. We got Mimamsa Nyaya Prakasha. I have not studied the entire Mimamsa Shastra. Only one book I studied. Under the guidance of a great scholar, Surya Prakasha Shastri ji. He is a Mahapadhyaya. But that book helped me a lot. Similarity between computer project management and Vidhi Bhaga. Once you are writing a project, means flowcharting will be there, program development, program execution, these are these things. They are called as Utpatti Vidhi, Vinyoga Vidhi, Prayoga Vidhi. Similarly, means of proof. How do you say, how I can take this as, I cannot take it for granted? Why should I believe your statement? What is the pramana? Pramanikata, standard. That is essential for our Vedic systems. Suppose you make a statement in the Supreme Court, immediately ask, yes, get the reference. You are supposed to get the article number of the Constitution, based on which you are making your logic. your presentation in the Supreme Court, there must be a reference for every word you are uttering in the court. Similarly, in the computer field also, yes, there must be a statement which is supporting that the purpose of that computer statement actually. Similarly, there are, as I told you, hereafter, sir, I request everybody to call Sage Pingala as the grandfather of computers. If you have any objections, please come out with logic, sir. Similarly, artificial intelligence, sir. Artificial, here I should conclude here itself. This topic is burning for only for last 2-3 years only maximum, not more than that. But in 1985, an article was written. 1985, about 40 years back. The first article I find on the artificial intelligence. You know what the Fatna author has written? He studied our Shastra called as Nyaya Shastra. Based on the Nyaya Shastra, he has written the first article on artificial intelligence, sir. I will take you to further previous history. Everybody must have known the name of Bhartruhari. Bhartruhari is one brother, I think a cousin brother of Vikramaditya of Ujjain. Bhartruhari is known for his Shatakas, Niti Shataka, Vairagi Shataka, Sringar Shataka, like that. But in fact, he is a great grammarian and mathematician. And he has written a book called as Vakya Padiyam. That Vakya Padiyam book is the source for our artificial intelligence, sir. If somebody wants to make any project work on artificial intelligence, let him study Sanskrit, let him study this Vakya Padiyam of Bhartruhari, sir. So like this, actually, there are a lot of literature is there. I think I have taken sufficient time. With kind permission, I am concluding, sir. Thank you, sir, for giving me the great opportunity for making this presentation before you all. Thank you.
Yes, sir. Thank you. Thank you very much, sir. Sir, your lecture is mesmerizing all the young minds, particularly. So we all here all below the major 40 years only, average age. So one of the professor, senior most professor is there. He might have many of the shlokas, I think so. So that the today's lecture, which you have drawn from the ancient time, so very mesmerizing us and given a real glimpse of the roots of mathematics and computers. The concepts which we have started, so from ancient time, and you have brought the number system from the Indian mathematics, the binary system, progression, as well as the infinity and various sutras for the Vedic mathematics from great Indian mathematicians and the computer concepts, and also you brought it the latest the trending concept, that is none other than the artificial intelligence. So now it is a trending artificial intelligence and machine learning. So it was also well written and well scripted in our Vedas, so that all Vedas are the main of our sources of all the contents which we are digging one by one, and day to day we are getting from that itself. Okay, so like a person, the personality are the source for getting such kind of information from our Vedas. So it is very thankful, sir, for giving such a great lecture, and that in your very busy schedule. So we really unfortunate. We are physically we have invited, and due to your busy schedule, it is not possible, not happen. Uh, okay, we will make it. We will make one more lecture sometime at your possibility for physically, and we will meet all our administration and all the main deans and directors are also. So we will surely we will invite you sometime, sir, and we will use your services to develop our institute here, and will be fruitful for the young minds.
Very nice of you, sir.
Actually, I would like to give one sloka as I know, and while that sloka is read, that might not be a sloka, it is just a quote. So in our campus only, while walking in the morning, I seen one thing. It was written near the Saraswati gate. That's Shiksharth Ayi, Sevarth Jayi. I thought all the students might have observed that quote. So that students are coming here for study and going for services. The seva is that is the main ultimate. So therefore, what we are here providing that seva, how to get it the seva and how to be trained for getting the for giving the seva to the society or whatever it is. So we seen such a great personality, and that the concept which you are giving serving to the nation as well as the people like us. So we are very grateful, sir. And it is my privilege to deliver the vote of thanks for this today's insightful lecture. And first and foremost, I extend my heartfelt gratitude to Dr. R.V.S.S. Avadhanulu sir
Thank you,
for
sir.
taking time to be with us today and sharing his invaluable knowledge and your expertise in mathematics and its various applications from ancient time to the modern world that has given us a deeper understanding of this field. We truly appreciate your efforts and in enlightening us with the research and experience. And I also would like to express my sincere thanks to Professor Peetam Singh sir for giving me an opportunity, such kind of activities which we can explore as a bridge to the students, as the point were clearly mentioned over there that the services which we are, so we will be providing at our level best. That is only of your support and encouragement, sir. And I especially thank to Professor Sudhat Kumar sir for his inspiring words and constant encouragement to materializing and happening such kind of events. So very recently we had also one of such a great we feel the expert lecture, and many of them have given good feedback for that, and that will be the motivation to go further and giving more such kind of lectures. That series of lectures we can plan and we can utilize our resources and our infrastructure. Oh, thank you, sir. This is as the without Shivadat sir, it cannot be happen. I really thankful for his support and encouragement, and I extend my appreciation and the support from all of our department faculty members for their active participation and making this event a meaningful and enriched experience. A big thank to all our organizing team, where particularly the research scholars, which tremendously and working overnight and making all these communications, that posters, everything it get it in time and making proper communication and smooth conducting of the program. The scholars behind the screen, their work is effortless. That means we cannot say no words for that. I'm really thankful for them. And I also very thankful for the faculty members, Professor Dr. Sadev sir, as well Dr. Shivam Gupta and Naren Bhatt for their active participation and encouragement for such an event. So it will be giving you more support to take further step to conduct such kind of lectures. And finally, I thank to all the attendees, faculty members, PhD and PG students for their enthusiasm and keen participation Your presence has made this event even more successful. And last but not least, so where we are sitting, it cannot be ignored. So there, the platform which we have from the Department of Electrical Engineering, whenever I go to the madam for requesting the seminar hall, so madam will give you very encouragingly, and whenever you want it, you can take it. And such a kind of encouragement which we have. So I am really thankful for providing such opportunity to taking this a good established infrastructure platform, and to the head of the Department of Electrical Engineering and office staff for providing all the facilities. So even pin to pin, they have checked and they have given all such support to get it successful of this event. We're really thankful for them. Sorry. So I am very, very thankful to our director, sir, for giving a necessary support, and that financial approvals at very quick time, very short time, sorry, not quick time. So without his support and encouragement, it has not happened. There is no word at all. So therefore, we all thankful to the director, sir. Okay, sir. Thank you, sir. Thank you for your valuable time is spending with us.
Thank
And
you, sir.
also, we have a plan, and we will inform you soon about his extending of his services. So we will surely utilize his services for the development of the institute as well as the department. So we will, due course, we all communicating, and we will request him for his valuable support and encouragement, sir. Without your support, it is not possible, sir. Please. Okay. Thank you very much, sir.
Thank you, Professor Rafiji. Thank you. Very nice of you.
Thank you, sir.
So I am closing it. Thank you.
Thank you, sir.
Nice of you.
Okay, sir. Thank you very much, sir. Thank you very much.
Namaskar, sir. Please convey my regards to all the great people.